Hello class. Today we're going to cover section 6.7, plane curves and parametric equations. This is the last course, or the last section that we'll be covering for the semester, so congratulations. Our final will be only on chapter 6, so please prepare for it. I will actually be giving you the practice exam this week, so you guys have a full 2 weeks to study and prepare. The final will be due by Thursday, December 5th, I believe it is. December 5th. So please work diligently and be prepared. Take advantage of this week and try and get everything done. But this is the last section that we're going to do. This section is just going to cover on parametric equations, and parametric equations are covered in this way. X is equal to a function in terms of t, and y is another function in terms of t, and t is called the parameter. So let's do some examples so you guys can see and better understand this. So here's our first example. We're given a function for x, and we're given a function for y, and then we're given the parameters for where t is. It's from -2 to 3. And so what I typically do with these types of problems is I'll make a table. And so this will be my t, here will be my x, and here will be my y. And so I know that the parameters are going to be from -2, -1, 0, 1, and 2. And then I'm going to plug those in for x and y. And so when I plug in -2 into the x equation for t, I'm going to get -2 squared, that's 4, times 3 will give me a 12. Then -1 squared is 1, times 3 will give me 3. 0 will obviously yield 0, and then 3 and 12. For our y's, we're going to get -4 because it's 2 times a -2, a -2, 0, 2, and 4. And now when I go to plot this, we're going to be in x and y. And so in fact, what I probably should do is move my y over even further. Let me move y over one spot. So this is 0, 0. Then 3 and 2 and 3 and -2. And then we're going to go all the way to 12. And for 12, we're going to get 4 and -4. So we're going to get these values, and this is what our parabola will look like. It really is kind of that simple. So let me do another equation, one that will be a little bit more complicated, and it'll actually give us direction, which is always something good to have. So here we go. For A, I'm going to work on the left-hand side. And so I see x is equal to a cosine t, and y is equal to a sine t. And the parameters are that I'm going from 0 to pi. And then my a is greater than 0. So what I'm going to do is I'm going to write this in terms of things that I know. So I'm going to divide by a and get x over a is cosine of t, and y over a is sine of t. And then using my trig identities, I can go cosine squared of t plus sine squared of t is equal to 1. And then I'm going to replace. So I'm going to get x squared over a squared plus y squared over a squared is equal to 1. And since our a is greater than 0, I'm going to be able to say y is equal to the root of a squared minus x squared. And my a is going to fall within negative a to a for my x values. And so the direction of this thing is going to go like this. The center is obviously at 0. And then let's call this a distance. And I'm going to get a half circle. And the direction that it's going in is this direction. And we can see that just by putting in our angles. And we see, all right, when it's 0, cosine is going to be a, sine is going to be 0. That's this point. And then at pi over 2, x is going to be 0 and sine is going to be a, and so forth and so on. Now, by that same reasoning, we're going to attack the part B question the exact same way. And so we're going to end up with, again, using the same substitution, but we're going to have x over negative a is cosine of t. Well, I'm sorry, not cosine, sine of t. That's important. And y over negative a is going to be cosine of t. And so what we're going to get is, again, cosine squared t plus sine squared t is equal to 1. So that's going to be y squared over a squared plus x squared over a squared is equal to 1. And when we clean this up, we're going to get y is equal to negative root of a squared minus x squared, where I'm going to go from negative a to a. And the reason that this is this way is because now when we're looking at this, these values, we're looking at it from a negative a point of view. And so if we plug in values to start this, if we plugged in 0, what are we going to get? Getting 0, we're going to get cosine of 0 is going to be, let me see. I'll try to get this so you guys can understand it. Cosine of 0 is going to give me a negative a. So, but that's my y value. So that's here. So I'm going to get 0, negative a, and then the sine of that is going to give me that 0. So I'm going to get 0, comma, negative a. And then when I do pi over 2, I'm going to get my x is going to be negative a, and my y will be 0. So I'm going to end up here, and then proceeding that, it's going to go this way. And so this is going to look like this as a half circle, and it's going to be going in this direction. Now, the important thing is when I'm plugging in these values, I'm plugging in to here to find out what my x and y coordinate values are going to be. So here I would have gotten negative a 0. Here I'm going to get 0, comma a. And that's how we plot and graph this. Okay, so this next example that we're going to do, and just going back to this real quick, these problems here just take plotting points, kind of like what we did with the previous one with t. So as you're plotting in theta values for t, that's how you're going to be able to plot this thing. Once you convert to x and y, you're plotting it on here as this is the x-axis, this is the y-axis, this is the x-axis, this is the y-axis. So just, it doesn't correlate to the polar coordinates, it's being switched back to rectangular coordinates. Now in this next example, we're actually going to be using x as a function with velocity and cosine with t, and then y is going to use gravity with velocity and then also a height. So this is important for you to know. So let me show you guys how to do this so we can go through this problem. So for example A, it's saying find the parametric equation that describes the position of the ball as a function of time. So I know that x is going to be equal to my v0 velocity. My initial velocity is 150 feet per second. So I'm going to get 150 feet cosine, and it gives me an angle of 30 degrees. So cosine of 30 degrees, and then times t, and that's going to be equal to 75 root 3 of t. And that's because cosine of 30 is radical 3 over 2. That's from the unit circle. And then finding our y is going to be a negative 1/2. And gravity, just so you know, is 32 feet per second squared. And I won't put in those units, but that's what it is. Times t squared plus 150 sine of 30 degrees times t plus our height. Well, the height that they told us was the ball was still on the ground, right? When you're hitting a golf ball, it's going to be on the ground. And just so you know, I'll highlight it. This came from here. This came from here. Just want to make sure that you guys are clear on where I got these two equations. This is going to clean up to be a negative 16t squared plus 75t. That is part A. It's going to be this piece right here and this piece right here. All right, for part B, it says how long was the ball in the air? Well, the equation that's going to deal with the ball in the air is the y, right? So our y coordinates are going to be negative 16t squared plus 75t, and we're going to set that equal to 0. Factoring out a t, I'm going to get negative 16t plus 75 is equal to 0. And so there's two possibilities. T is equal to 0, which obviously it starts off on the ground. And then a negative 16t plus 75 is equal to 0. And that's going to clean up to give me 75 over 16, or 4.6875 seconds. So it's in the air a pretty good long time. So we have that now. For part C, we're going to get max height. And so to find the max height, that's going to occur at the vertex of that y equation. So max height is at the vertex, right? Because a golf ball is going to travel like this. And so the vertex is where the height of the ball is going to occur. And so we remember that negative b over 2a is how we find the vertex. And so that's going to be a negative 75 over a negative 32 is going to be equal to 2.34375 seconds. So when was the ball at its max height? At 2.3475 seconds. And then it says, what is that maximum height? Well, that's easy to find. All we're going to do is substitute that time into our equation. So we're going to square plus 75 times 2.34375. And that's going to tell me that it's going to be about 87.89 feet of height. So this height is going to be 87.89 0.89 feet. Okay, pretty cool. Now the one thing too that you often are going to look for, and that's part D, is, well, how far was it from here to here? How far did the ball travel along our golf course? Well, to do that, that's just the x. So the x coordinate is going to be x is equal to 75 radical 3t. And well, that's going to be the total time. So that would be the 4.6875 seconds. And so to get that, it's going to be x is equal to 75 radical 3 times 4.6875, and that will yield 608 feet, 0.92. And that should really, that tells us how far we've traveled lengthwise. So this length would be 608.92 feet, almost 609 feet. That's pretty cool. Okay, kind of a tricky question is this one right here, and this question is basically saying find two pairs of parametric equations for the equation y is equal to x squared minus 4. Well, the easiest one to do typically is to let x equal t, and when you let x equal t, your y becomes t squared minus 4, and we're going to let t be anything from infinity to negative infinity, although we're not going to include the infinities because we never get there. Now, another way to do it would be, and a lot of people would think, oh, we should do, how about t squared? But t squared, what that ends up doing for us, and it messes us up, is it doesn't give us the negative values, because we end up with x is equal to t squared. That makes everything positive, and then when we put it into x squared, it'd be t squared squared, which is t to the 4th. We'd never get the negative values for it. So in this problem, because we have an even power, we need to use odd powers so that we can get both sides. So the next one that we would use would be t cubed, and then y would be equal to t to the 6th minus 4, and then going from negative infinity to infinity. And again, it's because this will allow me to have my negative and positive values for x, where if you use t squared, you'd only end up with positive values for x, and that's not something that we want. And that's important to remember. All right, our next example, we're going to find the parametric equation for an ellipse, and this is the ellipse that we're given, and we want to know in which way it's rotating. So we have two examples. The first is the motion around the ellipse is clockwise. It begins at the point 0,3, and it requires 1 second to complete a revolution. And that's important because really what that's talking about is the period. And so this is the ellipse. Terrible ellipse by me, but it's going clockwise, and so we're starting here and we're going in this direction. And so it's important that we know that. So we know that x is going to be a sine of some omega theta, and y is going to be cosine, ooh, it's messed up, 3 cosine of omega theta. And the reason that y is cosine is because if we start at angle 0, cosine of 0 is 1, which will give me a y of 3. And x is going to be sine of 0 is 0, so we get our point, which is right here, 0, 3. So that's how I was able to find it, to be able to go that way. Now, the thing that we also find is that our omega is going to be greater than 0, and that's because as x is getting bigger, y is getting smaller, and so our omega needs to be a positive number, or 1, right? Or it's got to be something positive, or it could just be 1. Now, the revolution piece is a good one. So we know that one revolution requires us to go a full period, right? So one revolution requires the period to be covered. And so if the period's going to be covered, that means it's got to be 2 pi over omega is equal to the amount of time it takes. And so what that implies that our omega is going to be 2 pi. And so what ends up happening is the equation that we get is x is equal to sine of 2 pi t, and y is equal to 3 cosine of 2 pi t, with our restriction for our time being from 0 seconds to 1 second. So that's how we get it to be going clockwise. And then to go counterclockwise, you guessed it, instead of being x is sine and y is cosine, it's going to be x is cosine and y is sine. And so this is for part B. I'm going to be x is cosine of an omega 3 or omega t, and y is going to be 3 sine of omega t. And since we want it to be counterclockwise, we want our x values to be decreasing and our y values to be increasing. And again, that's because in this case, we're starting here and going in this direction, counterclockwise. Remember, our first point was x is 0, y is 1, x is 1, y is 0, when our t is 0. And that's what helps us dictate our answers to this. And so with that, since this is happening again, our omega has to be greater than 0. It can't be negative, because or else that would make it so instead of x getting smaller, it'd be getting bigger. And same thing with y. Instead of it getting bigger, it would be getting smaller. So we have to make it positive. Now again, the period for a revolution is 2 pi over omega. But how much time are we allowed in part B? In part B, we're allowed 2 seconds to make that revolution. So instead of it being a 1, it's going to be a 2. And so that's going to tell me that I'm going to get 2 pi is equal to 2 omega. So then omega is equal to pi. Now substituting into the equations that we got, x is equal to cosine of pi t. Y is equal to 3 sine of pi t. And our parameters are from 0 to 2 seconds. And so that's our solution for this one. This is a solution for the previous one. And that's how we break down these parametric equations. I hope you found this beneficial. I hope you've enjoyed the course. Please let me know also when you'd like to make up the exams that you might have struggled on. Email me the day and time so I can unlock the exams so that you have access to them. Everything has to be done by December 5th, so please reach out to me so we can get that all done. I hope this class has been beneficial for you. And as always, all the best.